Hello, today we learn how to write the given numbers in scientific notation. So scientific notation is a specific way of expressing the numbers where the numbers are written in A times 10 raised to the power of B form, where A is any number less than 10 and here B could be any integer. So let us look into one example to start with. I'm taking a number 645,000. So if I have to write this number in the scientific notation, what I'm going to do is I have to check where is the decimal right now in this number. So if I don't see the decimal, which means the decimal is right over here, extreme right. And what I need to do is I need to move this decimal after the first non-zero digit. Our first non-zero digit is 6. So I need to move the decimal over here. So what I'm going to do is I have to move the decimal 1, 2, 3, 4 and 5 places onto the left. Keep in mind when the decimal is moved to the left, it has to be written as 10 raised to the power a positive integer. And when the decimal is moved to the right, it has to be written as 10 raised to the power a negative integer. So here, because we are moving on to the left, so the exponent will be positive. So for this one, the scientific notation is going to be 6.45 and the zeros we don't need to mention. This being multiplied by 10 raised to the power of 5 just because the decimal moved 5 digits onto the left. Now let us try a few more examples and get a better idea of this concept. The question over here says, write the following numbers in scientific notation. And the number is quite big. You can see that. Our first non-zero digit is this 2. And the decimal, because we cannot see it written down, so it is on the extreme right. To bring the decimal after 2, we have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places towards the left. So our answer is going to be 2.345 multiplied by 10 raised to the power of 10 just because we moved it 10 places onto the left. Now, for the next one, this is our question. And now, what we need to see is we need to locate the non-zero digit, the first non-zero digit, which is 3. So we need to have a decimal after 3. To do this, the decimal we can see right over here. So we have to move it 1, 2, 3, 4 decimal places to the right. So our number in scientific notation would be 3.56 multiplied by 10 raised to the power of negative 4 just because we moved the decimal 4 places to the right. For the next question, our first non-zero digit is 9. The decimal being right over here, we have to move it after 9. So 1, 2, 3, 4, 5, 6, 7. So we are moving it 7 places onto the left. So our scientific notation would be 9.2 times 10 raised to the power 7. Let us look at the next one. Our first non-zero digit is 8. The decimal is being moved 1, 2, 3, 4 because it has to come after 8. And now the scientific notation is 8.523 times 10 raised to the power of -4, just because you're moving it on to the right. For the next one, again, the same way, the first non-zero digit is 9. The decimal, because you cannot see, so it is right over here. We have to move it 1, 2, 3, 4, 5, 6, 7, 8 decimal places onto the left. So our scientific notation is going to be 9.32546 times 10 raised to the power of 8. The next one is 345. The first non-zero digit is 3. The decimal is over here. We are moving it 2 places onto the left. So scientific notation becomes 3.45 times 10 to the power of 2. The next one is this question, in which our decimal is over here and we have to bring it after the first non-zero digit, which means it is being moved only 1 decimal to the right. So our scientific notation becomes 9.65 times 10 raised to the power of -1, just because it's being moved to the right. And for the last one, our first non-zero digit is 9. The decimal, because we cannot see, it is over here. The decimal has to be moved after 9. So 1, 2, 3, 4, 5, 6, 7, 8. So it's being moved 8 places to the left. So the scientific notation is going to be 9.0 because we need to write at least 1 digit after the decimal. So 9.0 times 10 raised to the power 8. Just a recap to keep in mind: when the decimal moves onto the left, the exponent is positive, and when the decimal is moved to the right, the exponent is negative. Hope you understood and enjoyed the video. See you in the next one. Bye-bye.